That's neat. I'm kind of, you know, you open one door and you say, oh, you know, wow, I can do this too. He was like, oh.
Famous last word.
Yeah. There's got to be a booby trap out there somewhere.
If this were Los Angeles, you wouldn't have to apologize for being overdramatic.
What's that?
If this were Los Angeles, you wouldn't have to apologize for being
Oh.
overdramatic.
I just came from Los Angeles, so I guess I'm off.
Oh, well, take that apology away.
I'm just wondering how Rest took it, and if she's stalking you now.
Yeah, it's
Were you gentle, or was it brutal, you know?
it's too early to tell, really, but you know, we'll see.
All right,
We'll
so
see how
you
things
are
go.
all set.
Maybe friendship's a possibility. All right, so sorry, I know people are still eating, but you know, they'll be okay, I guess. So my name is Eric Streeper. I just moved, as you guys heard, I moved here from Los Angeles about 5 or 6 months ago. I was from Santa Fe, but I've been gone for like 12 years, so now I just kind of came back. So I figured, you know, how can I meet all of, what better way to meet all of you guys than have you stare at me for 30 minutes while I give a talk, right? So kind of make it easy on myself, I guess. So today I'm going to talk about, so I run a company called Zerb, and it's a subscription video streaming service. And one of the technologies that we've been using in it, which has been really good for us, and I feel like it's made us really productive, is this technology that came out of Facebook called GraphQL. And the idea behind it is it's basically an alternative to kind of these traditional REST kind of architectures that you would see. And they open sourced it last year, so it's still quite new. They've been using it in production, I think, since 2012. But yeah, so it's kind of for me it was definitely new, but it's been a really awesome experience working with it. So I just kind of wanted to talk about it. So first, I just kind of want to go over kind of if you're not familiar with kind of how REST generally works. This might be, I'm sorry, I know it's a little small, but you would have kind of you interact with these what are called these API endpoints, which are really just URLs. And in this case, you might have one that's that fetches all of your friends or fetches the user's friends. So you see it's a GET request. The HTTP verb for this is GET. So you're getting the user with the ID 3. You're going to get a list of like all of his friends, for instance. So REST also uses these other kind of HTTP verbs, like maybe like another common one is post, which would be like if you're appending data onto something or adding data to something. Put if you're creating a new resource. Delete. So it has kind of all these corresponding verbs, and so you might interact with it by kind of deleting friends or adding friends and kind of through these methods. So the way this would work is you would in your own code you would send this request to a server, and hopefully your server doesn't look like that, but and then normally it'll return you some data in like a machine readable format, so something that your code can take in and can parse. And the most common format of like kind of new APIs out today is JSON, and this is what it looks like. So if you made this request, you might get back a response that has this array of this person's friends, right? If the user with ID 3, it returns all their friends for you. So let's kind of take a look at like a real world example. So this is from the Twitter API. I use them just because they've been around for a long time. Maybe some of you might have even worked with them. They have good documentation. So this is one of the methods that they offer is get statuses show ID. And if you look at their documentation, you see that it says returns a single tweet specified by the ID parameter. The tweet's author will also be embedded in the tweet. Okay, so first of all, so you have to kind of translate in your mind statuses to tweets, but that's what they used. So, and this is an example of one of these actual API calls. So you can see up here, it's just kind of what we talked about, but they also have that 1.1 is just the version of their API. Statuses show, and then you see that the ID number is actually included as a query parameter in this case. And the response you get from that looks like this. So if this could continue on, it would go way down through the floor because there's so many fields and everything, right? But this here is what you get back when you kind of make this call in your own program. You get back this information. And let's say you're creating an app and you just want to be able to extract the text out of tweets, for instance. So what you might just need is this one field, right? The text of the tweet. However, there's only one endpoint. So you're getting back all this data no matter what, you know? So what this leads to, this problem is called overfetching, right? So it might not seem like that big of a problem, but because it's, you know, it's text data. It's not huge necessarily, but if you're making this call thousands, millions of times, then it adds kind of a lot of network overhead, you know? So it's something of an issue, right? And just to give you an idea of kind of what one of these API endpoints might look like, this is just in Flask. It's a Python framework. If you guys like Python and haven't checked it out, it's really cool, but it's really nice to work with. So you might set it up like this, and this is a little bit different because we're actually going to put the ID right in the URL. But so we have we declare this root, which is going to be statuses show ID, pretty much just like the Twitter one. And then what we do is we kind of tie this function to that, and what it does is that ID parameter gets passed into the function, and then we're going to make a database call. We're going to query our status table. We're going to pull back the tweet or the status that has that ID number, and then we're just going to take that thing that was returned, and we're going to put that into JSON. We're just going to dump it out into JSON and send it back to the user. So just to go back and look at this. So we have, this is the API call, right? Now, a few questions about this. Why not use get statuses /ID? You know, why the show? Why is the show in there, right? Or maybe get statuses /ID/show rather than, you know, appending the ID onto the end. Or why not just call it tweets instead of statuses, for instance, right? Since that's really what they are. And the thing is that all these questions, they really bring up this problem of like API standardization, you know? So if you're going to build an API, and we're kind of going back to our original example, if you're trying to pull all your friends, like you pull a list of someone's friends, we have all these different choices available to us of how we can create this thing, you know? And we each kind of have our own opinion on what might be best, and there's best practices you can follow. But let's say the thing is, it's really hard to tell right off the bat, like which one is kind of the right way to go, like which is going to be the best way to go. And what ultimately ends up happening is I end up I might end up doing something different from someone I'm working with, or different from myself in the past, or any of these things, right? And so what kind of ends up happening is you kind of lose this ability to standardize easily these APIs. So let's say it's a year later, and you're creating your API, and you have these two endpoints. So you've created, and you're looking through the code base, and you say, oh, look at that. I've got users ID friends, and I've got users ID friends show. Like, what's the difference between those, right? Like, how did those both get there? So you're like, well, I'll read the descriptions. The first one, okay, gets the user's friends. The second one gets the friends for user. And you say, oh, bingo. Same thing, you know? Like, let's just, what should we do? Let's consolidate this. Let's clean it up. Let's clean up the code base, you know? We'll just get rid of the second one. We like the first one better. And so everything's good, right? So you know you've solved the problem. Except you didn't solve the problem. Like the whole world just blows up because some mobile application that was developed 2 years ago is using that URL that you just deleted, or maybe some part of your website, and you just don't know where it came from, right? And so all these problems start happening. And what this really leads to is it leads to kind of a fear of being able to go back through and refactor your code base, because you're really afraid that if you get rid of one of these endpoints that seem so important, that why is it there? Someone obviously put it there for a reason, right? So something must be using it. So it makes it creates this barrier to being able to kind of go in and change it and make like meaningful changes to this. And kind of like a related problem to that is you end up also with this proliferation of these custom endpoints to get around certain problems that REST has, right? So let's stick with the example of getting, let's say that in this case you want to actually get now the status of your friends. You have your endpoint you created to get the list of your friends. So one way to do this might be, well, I'll query the friends endpoint, and I'll get my list of friends. I'll take all those IDs, and I'll feed those into another endpoint I have, which gets the status of each of those people, right? But this is, of course, now, this is kind of the problem here, right, is you're making tons and tons of network requests. and you don't know how they might be coming back at different times. Some of them might be failing, whatever, you know. And not only that, but in this particular case, because you have to know that list of friends beforehand, you're forced to make at least 2 round trips to the server. And so that's all latency we're talking about. You know, so if you have someone on a mobile phone that has 300 millisecond latency or something on their connection, now they're waiting at least 600 milliseconds to get that data back from you. So how do you solve this? You know, the way you usually do it, or what usually ends up happening is, all right, we'll make this custom endpoint, right? We'll just make it users, user ID number, friends, and get all those statuses at the same time, right? So it'll be nice. All the data will be fetched at the same time. Okay, but then there's a new problem, right? Now someone comes to you, I don't know, the business person or something, and says, okay, we also need to get like some suggestions for friends for this particular view we're making on our website, right? And so maybe you want to, you might want to get the 2 best friends of each of your friends, and maybe those are the suggestions, something like that, right? So you say, well, okay, I mean, what can we do, right? Should we just add this data to the original, or we're faced then with these kind of like overfetching problems, right? Or maybe you decide, well, okay, I mean, we made a custom endpoint before, that seemed to work. Let's just do that again, right? And in this case, like I don't even know what that would look like. So it gets very complex. You know, these endpoints just get more and more complex, and it gets harder and harder to understand your own code base. You know, so GraphQL came in trying to kind of solve these problems, and fundamentally the way that it tries to do it is it tries to declare what data you need on the client rather than on the server. So, and the reason it's called GraphQL is it's based on graphs, and so it's not that super important. But if you haven't seen them, so this is each of these it's just kind of a way of describing how your data is connected to itself. So each of these would be called a node. Each of these are edges, and so kind of a more concrete example, we'll look again at Twitter. So here's Jack Dorsey, Biz Stone, founders of Twitter, right? So they each got their user account on there, and they follow each other, right? So each of them would be a node, and then the connection between them is the edge. So they also have more connections and to these other nodes, which are their tweets they've sent out, right? So this is just mapping out kind of how all their data is connected together. And then each of those tweets is also going to have hashtags associated with it, which is another piece of data that's connected on here. And what's really interesting about this layout is that really you can describe all sorts of data like this. And most of the major sites that you know will use some kind of a layout like this, whether it be Wikipedia, who has authors which are connected to articles, and so on. This is often a very convenient way to describe kind of how data is laid out. We'll just look for this example. We'll get rid of the hashtag thing. We'll just look at kind of the tweets. So let me show you now what GraphQL actually looks like, so the language behind it. So let's say that Twitter comes to you and they say, hey, we're sick of these creating all these endpoints and stuff and all this overfetching, and we want to fix all these problems, right? Like, what can you do for us? And so you decide you're going to remake their API using GraphQL. So this is what a GraphQL query looks like. So in this case, you have this user, and you're passing in a username for them, which is in this case @Jack is Jack Dorsey's Twitter handle. And then what you do is you actually declare what data you want to get back, and this is all happening on the client. Keep in mind, you're not changing anything on the server, and in fact, for every request you make, you're hitting one endpoint. So then the response you get back looks like this. And what's really interesting about this is that if you look, the shape of the query you made matches the shape of the data that's actually returned to you, matches the shape of the JSON you're getting back. So you know exactly what you're expecting, and you're able to kind of declare exactly what it is you want to see. So now let's say you're making some view, and you want to add in also, you want to be able to also see his tweets, right? So all you do is we just took this last query, and we just add in this tweets field here, and we want to get the text of all those tweets, right? And so this is, if you think about it, this is when with the graphs, this is that connection between them, that connection to the tweets, right? So I'll just this will go up in the corner here, and then this is the query. And then if this is the data you get back for that. So again, all we've done is just change this one field, and we're getting back a completely new shape of data that exactly matches what we asked for on the client side, right? So the way GraphQL does this is, what it does is each of these nodes, it creates a type for them. And fundamentally how it's different is rather than trying to describe in URLs how you're going to get your data, so creating all these custom URLs, this URL is going to get me this piece of data, this URL is going to get me this piece of data. What you're actually doing is you describe your data and the relationships between that data, and then when you make a query, GraphQL is able to do all that for you and always just get you what you want, exactly in the shape you want it in one request, basically. So in this case, we have our user types and we have our tweet types. So without further ado, I want to introduce you to Santa Fe's hottest startup, dogs.party, party planning for your pets. And I have really good news if any of you are entrepreneurial minded in here, because it is available and it's only 88 cents a year. So if anyone's interested, Now I'm going to do a demo here.
Does that include the app underneath that name?
Sure, yeah, you can have it. It's on GitHub, so yeah. This demonstration I'm going to do is going to be it's written in JavaScript. Now I know some people have problems with JavaScript. I kind of count myself among them. So if you don't like to work with JavaScript, it's fine. This is actually, it comes in many different implementations. One particularly good one I think is that I've worked with is this Graphene, which is Python. As you can tell, I'm kind of a Python guy. But they have them for Ruby, they have them for Java, .NET, PHP, basically almost any language you can think of, they have some kind of an implementation for. So you can do it in whatever language you like to use. So then, just before I get into the demo, I know this has kind of been, some of this might have been kind of abstract, and hopefully it'll be kind of cleared up when we go into the demo itself. But first of all, I just want to say, so the code I'm going to show you, if you want to take a look at it, it's on GitHub, so you can just you can grab that if you want. And if you ever have any questions, if you do decide you are interested in this technology, right, and you want to look into it further or whatever, or have questions, feel free to reach out to me. My email address, I'm on Twitter, I'm on Facebook, and it's pretty easy to find me. There's not a lot of streepers in the world, so it should be pretty simple. So I guess I'll stop there for now and just see if there's any kind of questions about the presentation, kind of before we get into the demo. I don't know if you guys have anything that's not clear, or yeah.
So I have a question that's really not clear to me where the distinction is between the REST API and GraphQL in your example, because the query you showed, I can map that, I assume you post that, you have that as the content of a post request, but I can also map that to URL parameters, and then I have an API endpoint, and it's really the modeling of data on the server side that then, based on the query parameters, allows me to return JSON in a particular structure. And I have implemented APIs like that, and I would consider them REST APIs.
Sure, yeah. So I mean, well, fundamentally, I guess the difference, and I think in my mind the main difference is kind of where the data is being declared, like where the data is going to be returned, like where that's being formed in a way, So so of course, GraphQL is putting it together for you, but the difference is that like every time I send a request, I'm always sending it to api.example.com/GraphQL. That's the one endpoint, right? And then all of it is just contained in the body of this post request, So I think what that's done, at least for us, I think, is it's really kind of greatly simplified the development, because we no longer have to even think about like, what endpoints are we going to have, how are we going to have them structured, all of those things. Kind of a lot of those problems, I feel like it allows us to kind of.
Okay, but that's exactly my question. So I work with bibliographic data. I adhere to the MARC XML 21 standard. There's over 800 fields with dozens of subfields. So I have like 1,000+ different fields, easily actually 10,000, but it doesn't matter. They're documented by the Library of Congress, and I can assign name labels to them, and I can request specific fields and subfields from that tree hierarchy with just using that name as a query parameter in the GET request, I get exactly that piece of information or the pieces of information I want, and it's the same endpoint. It's inspirehelp.net/API/ give me the first author of this record.
Yeah, well, I guess I would
So
say.
that's why I'm saying I'm not entirely sure what the fundamental difference is.
Okay, well, yeah, I mean, I think, so, well, where REST has come up with kind of some solutions to this problem, right, which it sounds like you've probably implemented, where you can actually, you can kind of specify the fields and everything that you, like the exact fields you want to get. However, you know, not all APIs work like that, and it was probably, I mean, I don't know the specifics of your implementation, but it was probably a lot of work to implement, I assume, right? I mean, it's...
Which is why I say the data model at the server side is important, how you can map it, but if you natively store your data in JSON data structures and you request a particular entry of a particular dictionary, that can be served very rapidly. But what I'm seeing, I guess, is your query really has the, you know, the post content has the JSON dictionary structure already that you expect to come back filled with content instead of flattening that to query parameters. And you can't flatten all dictionary structures if they get complex enough.
Yeah, right.
You hit a wall there. But yeah, I'm trying to like
Yeah,
get what I'm really getting out of GraphQL where the paradigm shift is, I guess, is what I'm trying to.
I have a question about this question. So in your API, if you want 6 out of the 10,000 fields,
Yeah.
is that 6 calls or 1 call?
6 query parameters.
6 query parameters.
Order doesn't matter.
Yeah, all you have to do is you take your REST call, and at the end of it, and again, this is a horrendously badly designed Twitter REST API. I mean, and whoever designed that should be shot. But to say that you need to go to something else to get that functionality is wrong. Because you could just put at the end of that REST request, ampersand fields equal name, comma, address, comma, zip. And you've got one request and it's only going to bring those fields back. Whoever wrote that was A, in a hurry, B, just out of school, and C, not at the top of his class. So that REST API is awful.
Yeah,
and I agree it's awful.
It breaks backwards compatibility all the time, which is why you need the version
Well,
information. Again, I'm not trying to give you a hard time here.
Yeah, no,
I'm trying to understand the paradigm shift.
Well, where I would see maybe running it, where I would see like one major issue would be if you had any kind of nested data, you know, like then there's no easy way to specify that in a query parameter, you know. So I mean, the query parameters fundamentally are you know, they're flat, right? So if I have this data that's very hierarchical, which most data is, you know, well, you know, or at least a lot of data, you know, it makes it very kind of, it makes it difficult in that sense, I guess, just to be able to do that through query parameters. Like I don't know how you would do that.
The problem is you want to do 2 things. And I don't know if GraphQL can do it. If it can, I mean, we're still at the beginning of this thing. But you want to have flat data that will cover 80% of your queries. Then you want to have flexible relational type of queries that will allow you at the query end, not at the server end, to define the relationships among the data.
Yeah, and see, this is the thing that, so REST has come up with a lot of solutions kind of for this problem. However, I think, what I think is a major draw for us is ease of implementation. You know, so these things are not easy to implement. Like hate OS and all that stuff is difficult. But you know, it requires a very specific way of doing things, and it requires a lot of work up front to kind of get it working. And for us, I think for me, what, you know, kind of the big thing is that I think the mental model of how this works just kind of makes more sense to me. So it's like my data it does have this structure, right? It has this graph structure. It has this hierarchical structure. And so to me, working with this has been simpler, I feel, because of that. I feel like I can be more effective. I've been more effective working with it for those reasons. So, you know, like to me, actually, I think I could stand up, I think, a GraphQL API way quicker than I could a REST API. You know, and the REST API would not, well, at least in my case, right, would not be nearly as good. So I think for those reasons, that's kind of why I think those have been the draws for me. And certainly REST has come up with solutions for this, but they're hard to implement. I mean, it's not free. So
And I would argue with all of that. And your thing about the hierarchical, the whole thing that came about in the 1970s when Ted Codd designed SQL is hierarchical databases force you to traverse in the hierarchical path. And you want to be able to relate data in paths that are different, that you've never tried before. So there's a drawback to doing hierarchical. That's why I say 80% of your work, fine, do it that way. But that other 20%, you need a way to get at your data differently.
yeah, I'm not sure. I mean, I'm not convinced that REST, that kind of solutions that REST come up with is gonna be
These are
answered,
abstract questions because I still don't understand GraphQL. So I'm just telling you some of the concerns as you're talking, what I'm thinking.
Yeah, maybe we'll probably get a better idea. Oh yeah.
Well, I have a funny question, but what is GraphQL? Because you talk about the syntax. Are we talking
Right.
about syntax, a transportation mechanism, an abstraction between your database and the query? What
Yeah,
is
so that's
GraphQL?
actually a very important question, right? So GraphQL, it has nothing to do with databases, none of that. It's a layer essentially it's a layer in between, right? So it's just a way of structuring the underlying data, and as we're going to see in the demo, so it's both a language and it's also this basically an implementation of a server that can understand this language and they can translate that language into the underlying database calls and those types of things.
So can I have any type of database in the backend and
Yeah.
it's going to be magically?
And any type, yeah, it's meant to be completely decoupled from it, yeah.
But
So-
how is that possible? I use object-oriented database at all. I don't see how this can work. I mean,
Yeah, let's get into the demo, and I think you'll see. I think that'll clarify kind of that particular question. I think you'll see kind of how it works. But really, how you're getting data now, you do it the exact same way. So it's really just it's a layer between that, which maybe unless there's more questions, maybe we can just kind of go into that and take a look, just so you can kind of see concretely what this is all about. All right. So for those of you, who aren't familiar with Node, there's a few files in here. You don't really need to worry too much about them. I'll show you real quick the server file. This is basically just boilerplate. So what we're going to do is we're going to just create a single URL here. Can everyone see this, by the way? Is it legible? Okay. So we're just going to create this single endpoint, and we're going to use that endpoint. We're going to pass basically the GraphQL queries to that endpoint. And then we'll start the server, and that'll be that, right? The other thing, so I created here, so normally, of course, you'd use a real database and all that, but for the purpose of this demo, I just have this mocked data, just stored in these variables. So I have like dogs and different, they've got ID, number, breed, and owner ID, those things. I've got humans, and I've got parties, right? So these are kind of all the things I'm gonna need, and just the fields that are in them. And then I've also, so these here, these are going to be what you would see. So these functions, these are obviously mocked functions because it's all fake data and everything, right? But this is what you would use normally to query your database. These would be like the functions would actually get the data out of whatever database you're using, however you're doing that, And so you'll see how those come into play later. The real meat of all this, though, is this is the schema. And this is where, when we look back at these types and all that, these user types and everything, this is where we're actually declaring all of those and how we're describing what those types are and what our data looks like and how it's related to the other pieces of data. So we have some just kind of the GraphQL endpoints, but let's look first here. This is the dog type, right? And so what this essentially is, this is just a configuration object. There's nothing, it may look like a lot, but there's nothing too crazy about it, right? It's just set up in a very specific way. We give our type a name, we give a description, and then what's important here is we have this list of fields. And so what these do is this is where we're actually going to declare what data should be you should be able to query on this type, or you should be able to get from this type. And so for each one of them, each of the fields itself has its own type. And what's nice about that is like you can see this first one. So I'm declaring that this is going to be an ID type, and that it also should not be null. So you see, we put this constraint on there. And what's nice about this is that because it is types, you get all this kind of free checking and error handling that the GraphQL does just out of the box, without writing any kind of error checking code or anything like that. It's already done kind of a lot of the work for you, which is really nice. Now, a couple of these you'll see, like the ID and the name. Those are just the same as those are just fields that are actually already existing on our on our dogs. So, however, you'll see this other field here, owner, right? And here we have an owner ID, which of course normally in a relational database would not be there, but for the purposes of this, that's where it is. So we don't have this field. So what we actually have to do for this particular field, and this is where kind of those connections come in that we were talking about. So these edges here. So how do you say that a user has tweets, right? And in this case, so how do you say that a dog has an owner? And that's what we're doing here by. So you see, we have a very similar setup, except in the type, you'll notice we have actually the human type, which we've declared later on here. So we have our description again, but then what's important is we have this resolve field, and this is where kind of all the magic happens with GraphQL, and this is where you tell it how to get this data. Because you have to tell it, it doesn't know, right? It doesn't know how to fetch things from your database. It's because it's completely decoupled from that. So what I've done here, I pulled in our function getDogOwner, which was, so this object, this dog object, is going to be passed into this because it's the dog type. And then so all I'm doing here is just doing getDogOwner, the dog's ID. And then that's going to query my database, or in this case, of course, just pull out of my variables. It's going to query the database and return that data to this, and that's how GraphQL knows how to resolve the types, and it knows how those connections are formed. So you'll see this is kind of repeated. So we also have a human type, which is going to be very similar, right? We've got ID, first name, last name, but then also we also have this is a bidirectional relationship, right? So we've also declared on this, we've declared that an owner can have dogs, and again, what we've done is we've given this field, we've told it how it can be resolved. We've told GraphQL how it can actually resolve this field. And so it's just with this function that passes in the human, and then just gets, runs that.
Where's own dogs defined? I don't see it as part of this class.
It's imported from that data file. So that in the data file, that's where all of our functions were just defined down here. So it's that one there, right?
Oh.
So yeah, so we've just, those are all those mocked functions, like my fake database requests, those are all just imported into the schema, and then the schema uses them, right?
Eric, obvious question, but this is your server-side code?
This is the server-side code, yeah. Mm-hmm. Right. Exactly, yeah. So you'll see that basically this, I mean, it's a little bit different because the fields are different, but